All right, let's take a look at our 8-4 notes. We're going to do some actual math with logs. So the properties of logs and what we can do with them. Let's refresh our memories on what a log is. And remember, we have if we have log base b of n equals p, and that means b to the p power equals n. So a base raised to a power equals a number. All right, so we have several properties, just the way that we can do addition, subtraction with exponents, we can do the same thing with logs. And so if the log base be of m times n, so multiplication is actually addition for logs. So this is going to be log base b of m plus log base b of n. And we can either condense it, so we take two logs and make them into one, or we can expand a log into two pieces depending on what kind of information we're given. So let's take a look at number one. So we have log base 2 of 7 plus log base 2 of 4. We're adding here. They have the same bases, so we're just going to multiply these. So we get log base 2 of 7 times 4. So log base 2 of 28. And 2 to what power is 28? There's not really a round number, so we're just going to leave this. It told us to simplify if at all possible. All right, look at number 2. This is log base 10. Remember, if nothing is written there, that's a 10. We're doing some addition. These have the same base, so we're going to multiply these two. So we get log, the 10 is implied, of 25 times 4, which is just log of 100. Well, this is a base 10, so that means 10 raised to some power is 100. And that's if I make this thing equal to x. Well, 10 to some power is 100. Well, 10 squared, so x is 2. So that's as simple as possible. All right, last one. We once again have addition. These have the same base, so we're going to multiply these two. So we get log base 4 of 2x times 4x squared. And 2x times 4x squared, this is log base 4 of 2 times 4 is 8, and x times x squared is x cubed. All right, so these we condensed. Let's take a look at expanding these. And we've got a couple of different options for this one. So if we do log, remember this is base 10 right here. Well, 6 times 2 I could split into 2 and 3. So this could be log of 2 times 3. And this multiplication we split into addition. So this becomes log of 2 plus log of 3. All right, let's take a look at this one. Well, 45, I could split that into 9 times 5, or 3 times 15. We have a couple different options. I'm just going to do 9 times 5. So we get log base 7 of 9 times 5. Because we're multiplying in here, that means I'm going to turn it into addition. So this becomes log base 7 of 9 plus log base 7 of 5. All right, last one. This one is really, so this is 5x, but this is really 5 times x. So log base 2 of 5 times x. Since we're multiplying in here, that means it's going to become addition. So we have log base 2 of 5 plus log base 2 of x. That's it. So using this product property, so remember when we had exponents and we multiplied, we added the exponents? This is very similar because those are related to one another. All right, let's look at the quotient property. Quotient means dividing. So we have log base b of m divided by n. Well, multiplying was addition, so dividing is going to be subtraction. So this is going to become log base b of m minus log base b of n. Simple as that. All right, so look at this. And once again, we can either condense it into one log or we can, sorry about that, oops, or we can expand it. All right, so let's condense this into one log. We have the same base, so this is going to become divided by, because this is minus. This becomes log base 3 of 24 divided by 8. Well, 24 divided by 8 is 3, so this is log base 3 of 3. This is really 3 to the x power equals 3. 3 to the x equals 3. Well, this has to be a 1 because 3 to the first power is 3. So x equals 1. All right, let's take a look at these. These have the same base. This is subtraction, so we're going to divide. So log base 2 of 15 divided by 15. Well, 15 divided by 15 is 1. So this becomes log base 2 of 1. If this is equal to x, that means 2 to some power x equals 1. Well, 2 to the 0 power is 1. So x in this case has to be 0. These are both going to become very handy in a couple of minutes. All right, next one. We have log base 4 of x to the ninth minus log base 4 of x squared. They have the same base, and we're subtracting, so we're going to divide these. So we get log base 4 of x to the ninth divided by x squared. And just like we refreshed our memories on the warm-up, when we divide, we subtract exponents. So 9 minus 2, this is going to be log base 4 of x to the 7th. All right, so we could expand these as well. And there's lots of ways we could get to 4. I'm just going to say 8 divided by 2. Okay, so this is going to become log base 8 of 8 divided by 2. Because 8 divided by 2 is the same as 4. Well, we're dividing here, so now we're going to split it into subtraction. So this becomes log base 8 of 8 minus log base 8 of 2. And we could actually split this. This becomes 1, and then this would become 1/3. I'll allow you to figure that out on your own. So this whole thing would actually be equal to 2/3. So 2 divided by 3. I'll let you figure that out on your own. Okay, take a look at this one. So we're going to split it up. This is division, so this is going to become log base 5 of 1 minus log base 5 of 3. This thing's going to become 0 because 5 to the x power is 1. Well, that x has to be 0, so this thing is 0. And so we'd actually end up with 0 minus log base 5 of 3. We don't have to write the 0, obviously. All right, last one. We're dividing. So we're going to get log base 10. There's nothing written here, so we assume it's base 10 of m minus log of 7. That's it for the quotient rule. All right, power property. So once again, so remember when we raise a power to a power? This is fun because we can actually move this exponent out to the front. So this becomes n times log base b of m. And we can either condense it or expand it. So this thing's already out front, so I'm going to move this as an exponent. So this becomes log base 4 of 2 to the 5th power. So I moved that out. Well, 2 to the 5th power is 25, so no. 2 to the 5th power is 32. 2, 4, 8, 16, 32. It's late. Sorry about that. So this becomes log base 4 of 32. All right, next one. This 7 I'm going to move as an exponent. So this becomes log base 2 of x to the 7th power. And the whole thing's not being raised to the 7th power, just the x. All right, next one. So this 1/3 is going to become the exponent on the 8. So we get log base 10, because there's nothing written here, of 8 to the 1/3. This means the cube root. Well, what's the cube root of 8? It's 2. So this becomes log of 2. All right, these we condensed, so we had one log. These we're going to actually split up. So every time this exponent, because it's the power property, is just going to move out front. So that 7 moves out front. So this becomes 7 log base 2 of 8. Well, this thing means 2 raised to some power is 8. Well, this is 2 to the x is 8. Well, what's x? X is 3. So this becomes 7 times 3, which is 21. So look at this one. So log base 2 of 8 equals x. So 2 to the x equals 8, and x equals 3. That's how I got that. All right, next one. All right, this one already actually has a coefficient on the front of it, so we're just going to multiply this out. So we still have the 3, and then the x minus 1 got moved out front, and then log of 4. And this one. All right, this looks kind of confusing because we have a square root, but remember we can turn that square root into a fraction. So this actually becomes log base 7 of w to the 1/2. Well, we know how to deal with these exponents now, so that 1/2 is just going to move out front. So we get 1/2 times log base 7 of w. Oops, sorry about that. So that just moved out front. And that is it. Those are the 3 properties. You will use them a lot, and on the next video, I'll just do a recap so you can have a nice little organized description of each one of these.